Phytoplankton are more important than a lot of people think. These tiny aquatic plant-like drifters provide half of the world's oxygen and a base for coastal food webs. But they can cause problems if they get out of balance. For example, in estuaries, if, say, agricultural runoff adds a bunch of nutrients to the water, it can cause eutrophication. And this can stimulate phytoplankton and other producers to grow rapidly, sometimes taking over ecosystems and harming other animals like fish. So it's important to know how phytoplankton growth impacts estuarine food webs, like the one shown in this figure. Now, this shows how nutrients cycle through the major components of the food web, but I want to look specifically at the phytoplankton to see how they function within this structure. So my thesis aims to break the phytoplankton down by size to figure out how specific sizes of phytoplankton take up nutrients in unique ways and transfer them to consumers. So I did this by going to helping with an experiment up at the Plum Island estuary in Massachusetts. Over the course of 10 days, a stream of nitrate was added to the tidal creek shown in this map. And it was labeled with an N15 isotope tracer to be able to track where it went and who consumed it. I took a series of water samples throughout this experiment and measured the different amounts of phytoplankton of specific sizes over time. Now, I found that the smallest phytoplankton, shown by the teal line in the graph, grew a little bit but didn't really do much. The medium-sized plankton, which are the purple line, and the big ones, which keep in mind big in this case means the width of a human hair about, they showed more peaks and troughs. And I was particularly interested in this large peak by the nanophytoplankton, the medium size. On this day, I found that it corresponded with a lot of zooplankton grazing. And so this indicates that the phytoplankton community is structured by both nutrient inputs from the bottom and zooplankton consumption from the top. The next step I want to take is measuring the amount of N15 tracer in different phytoplankton sizes to see how they took up the nutrient. And I also want to look at the caloric content of different sizes to see what nutritional quality they were each bringing to the table. I hope that my research can help us better understand how nutrients impact estuaries. Thank you.